Push the live button.
Live. I'm alive.
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 Is the microphone picking up? So you can hear me say the same thing.
I'm alive.
Is the microphone picking up? So you can hear me say the same thing.
Do you need 13 more cameras?
Well, how many more cameras you got?
I have another one.
Which one do you have?
One of those.
Ah, see, Jared, I told you we had another one of those. We just like rushed to Memory Express to go pick one up because he wasn't sure if there was any more.
Wasn't like this. Don't fuck.
Oh, Jared. That's okay. He picked one up anyway. We just like rushed to Memory Express to go pick one up because he wasn't sure if there was any more.
Wasn't like this. Don't fuck.
Oh, Jared. That's okay. He picked one up anyway. We just like rushed to Memory Express to go pick one up because he wasn't sure if there was any more.
Wasn't like this. Don't fuck.
Oh, Jared. That's okay. He picked one up anyway. We just like rushed to Memory Express to go pick one up because he wasn't sure if there was any more.
Wasn't like this. Don't fuck.
Oh, Jared. That's okay. He picked one up anyway. We just like rushed to Memory Express to go pick one up because he wasn't sure if there was any more.
Wasn't like this. Don't fuck.
Oh, Jared. That's okay. He picked one up. if I got any audio working here. Just making sure you guys can hear. Type something if you can hear me. Burn. Okay, really quiet. How about that? Test. Test one. Test. Test. Oh, that's better. Cool. Alright, let's add some cameras. Camera. Video capture device. Full room. I wonder if there's like a limit of how many capture devices you can have on this software. Maybe that's why it's not working.
Yeah, you're right, actually.
Mm-hmm.
You can just do 2 cameras and that's it.
Yeah, because I can't seem to add that one camera. It says no. No camera
No,
for
actually,
you.
I had 3 cameras going at the same time.
Did you?
Yeah.
Wonder. I don't get 3 cameras. I only get 2 cameras. Hmm. What?
Oh, there we go. Okay. What's working?
Camera. There we go. Perfect. Test. 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 Okay, now we just need some music in the background and some cameras on.
6.
Jock Jam. Big Shiny Tunes. Much Music's Big Shiny Tunes.
Should we do like, are we gonna do some streaming off of Spotify?
How about some beach music reggae?
It's not summertime.
It is for me all the time.
What's wintertime music? Let's do some wintertime music.
Is there such a thing?
I don't know.
Bum, bum, bum. Okay.
This is silly.
What?
Can't get my third camera to work, but I know it's working.
Just turn one camera on. What camera is not getting to work?
This one.
Oh.
Good.
How many cameras do you need?
All the cameras.
Dum, 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 dum.
Whatever.
You got it?
Yep.
What do you have to do?
Just like close the program and then open it up again.
Really?
There we go, 3 cameras. Did it. Alright. Hello. Okay, perfect. Start stream. It says I'm live, but
But you're not live?
am I? I don't know. I am live.
You're live.
That's beautiful. Great, alright.
So what are you gonna do today?
What's
your hack gonna be?
Work on Voltron. It's been a while, but we're gonna revisit it. Oh yeah, New Age Tommy's here. Alright. It's time to pull out some parts. My box of Voltron. Seems to be some lag. I can't see myself live yet. But, I'll just throw it on OBS. There we go. Here we go. Let's take out all the parts.
Oh yeah, you're doing Voltron. That's gonna be cool.
That Voltron sword. I think there's a name for the sword, but I don't remember exactly what it was.
Voltron sword.
No, it's a flaming sword or something like that. Yeah, I forget.
The flaming sword.
Form the head. Yeah, Voltron was definitely one of my favorites. I think it was my first taste of anime when I was growing up.
We should switch cameras. This one doesn't have a very narrow view. Cool. Okay, so I think the first thing we're gonna do today is Dynamexels, right? That's what we talked about. So I got this guy. We'll play with him maybe later. Let's first show the different Dynamexels and how to connect them, because I know that Will and some others want to know how the cables go. So I'll put him off to the side here.
Oh, my camera's sold out. DJ?
Uh,
Here?
Oh yeah, grab it. Okay, our dinner just showed up.
Oh, that's funny. Well, that picture, the upper picture is just going to be a picture of my arm. Like
Cool.
their camera. Oh man. So funny. Unless, oh, I have an idea. Bear with me, guys. I'm just gonna try something here.
What are you doing? Did you grab the pizza?
Nice. There. Okay. Another shot of my face, but yeah, I'll switch that to. Oh, sorry. Switch cameras here. Really making everyone watching sick
You what?
by moving this camera around so rapidly. Okay. Let's tilt this a little more so you can see the desk. There, we're back. I'll just take that away. There's a little bit of glare on there. Okay, I think we're good. Oh, okay, delayed audio. The audio is repeating itself.
That's because you had the microphone on. Once you turn it off, okay.
I don't have an onboard mic.
You were playing it back through YouTube.
Oh. Close that. It will be good.
No, you just have to have your speaker turned off.
Speaker of this. Yeah, it's muted.
The video is blurry? Hey, you guys got clear images now? Also, I'm eating a piece of pizza, so you have to wait. That's my dinner. We ordered pizza so we can snack a bit before we start hacking. Hey, what's up, Will? Yeah, you guys are gonna have to choose the resolution to be higher. For some, I just went to test it too, and it seems like it's defaulting to 144p, which is pretty awesome. And if I get really boring and slow,
I should post.
Jeremy's got his camera up too, so you guys can watch.
I
He's building a Voltron tonight.
should post your link on my thread.
Why? People will see it.
Yeah,
Yeah, on the homepage.
yeah, true.
The butter chicken pizza's gross.
What's the difference between desktop audio and input capture? I see some weird stuff happening on the bottom levels here.
I just turned mine down all the way.
Yeah.
Mm-hmm. Because I think it's picking up the microphone that's inside the laptop. So I turned mine all the way down to the bottom. All right. Okay, so let's do some Dynamixel servos. Cool. Let me switch so you guys can see full screen Dynamixel servos here.
I'm gonna grab some pizza. Everyone check out DJ's stream for a little while.
Well, so moving some images around here so we can get some more stuff on the screen. There we go. Lots of servos to play with tonight. Plus, Robotis sent me. Check these out. Did I update? Yeah, I updated the Dynamixel plugin tonight or this afternoon. So you guys are, if you want to follow along, you should get it. The update. So Robotis sent me a bunch of servos here. Let's see. I got. This is the OpenCR board that they use. So I'm going to take this and we're going to put over the next week or so. I should be able to play with it maybe this weekend. Because it's an ARM chip. It's an STF74, which is 2 series newer than what we were using instead of the EZB. So I can actually put the EZB firmware on here if I wanted, and we can actually just publish that so you guys can download it and install it on any of your ARM chip boards as well. But it doesn't really give you a lot because you can't do audio with this, and you can't do streaming video with this. All you would be able to do is control servos. So there's not a lot of advantage, but it's kind of neat just to play with. And then they also sent me this Robotis OpenCM board. I don't know. I'm not a huge fan of this thing. It doesn't come with any pins. You can't really connect anything to it. I don't understand the point of it. But I guess it's for hooking up servos, and I think it's got like an Arduino on it. So again, I don't know. You can't do any audio or video, so it's not super useful. But I got a bunch of cables, and they sent me these servos. So let's take a closer look at these guys.
Remember the name now. It's Blazing Sword. That's what this is.
Blazing Sword.
Blazing Sword.
So this is the Dynamexel XL 430. This is like a $350 servo or something. It's crazy. And then this is an XH 430. I don't know what the difference is between the XL and the XH. I know the 430 on Dynamexels is the dimensions. So the numbers I use on them is the dimensions. And then this one here is an XL 320. So this is what they use in the Darwin Mini. That little tiny Darwin Mini robot. And this one, which is the most popular, of course, everyone loves it, the AX12. So I recommend these ones because they're the easiest to work with, and they're affordable compared to these guys. Will, which ones are you using?
There's the head. I put RGBIs in here, but I do have to replace these RGBIs.
Okay, the XM64.
I hooked them up without
So I don't have an XM, but I have XL and XH. So let's look at some of the connectors in the back, and let's see if, Will, you can find out what size connector you're using versus what I have here. So you'll see, let me pull this off here.
So just using isopropyl alcohol to remove the hot glue. It works wonders. So what I'm doing with Voltron is actually upgrading the servos. They used to be all analog. Now I'm going HDD.
Okay. So I'm not sure which connector type. So this one here, I think when it's this many wires, there's 4 wires on this one. I think this one is made for the RS485. And that's similar to like it's a UART as well. But I also do RS232, I think, and it'll do, they're bidirectional RS232. And then this one with the 3 wires, this one is from, yeah, this is from the XL series. The TTLR3, yeah, that's right, the TTLR3. So this one on the XL series is 3, and then these other ones are all 3. So let's start with the AX12, because then we'll get into Will servos. Because I think I was doing some research earlier today, and I have some interesting discoveries on Will servos. So yeah, of course you're excited. You've been trying to get those servos working for a long time, so I think this will answer a lot of your questions. Okay, so we're going to use, well, you have to use EZB V4. If you have an IO Tiny, you can't read positions because there's no bidirectional communication on the UARTs. But on the EZB V4, we're going to use the bidirectional communication and demonstrate how to read data. So we'll just use I'll move these guys out of the way for now.
Oh, now we can music.
Why didn't put music on, Jared? Why don't you throw some tunes on? It's actually hard to like move things around on the desk like this. Looking at the camera. There we go. Cool. Disconnect this plug. Alright. So I'll disconnect all these wires, and first I'll show you how this wire works. Okay? So what I did is we took the end of the Dynamexel cable, and just a little quieter.
Sure.
A little louder, right? Maybe that. Okay, cool. So this is the end of the Dynamexel cable here. and you'll have to look at the schematic to see, but you'll see how this is like the flat side is here, and this is the non-flat side. And I wonder if this camera's blurry because it's dirty. I'll check cleaning the lens.
Want a Q-tip?
Yeah. Do you have a Q-tip? Thanks.
Alright, I gotta find shoulder seals.
Let's see. Doesn't help. Alright, we're gonna switch cameras. Yeah, they don't clearly mark. Yeah, I know, they don't mark the plus or anything very well. In fact, when I was looking at the data sheets, it wasn't very easy to find any of the information. And their data sheets are tough to use as well. So we'll go over that as well. I'm just going to switch these two cameras out. So 1 second here so we can get a clear image on the other camera. The one that's doing the whole room.
Maybe I'll have it back like this. For reference, a picture.
We just searched classic rock.
Yep.
Yeah, these cameras kind of fit inside of the tripod. Not very well.
Did have it that way, I guess. There's a picture of Ultron from the Instagram account. Bot Matrix on Instagram as well if you want to follow me.
Dun, 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 dun.
Might as well.
Okay, this will be way clearer.
On my channel. Let's go.
Oops.
Fill that with that blue one already. We're gonna have to be doing a whole lot of hot glue tonight.
There we go. That's better. All right, let's switch these two cameras.
One waiting for the hot glue to warm up. We're gonna work on these LEDs for a minute.
Oh, that's better, eh? Look at that. Now we can see. Cool.
Oh, so you're starting to look at.
Look at that. That's a great camera. Like, this camera is really good for,
Oh yeah.
yeah. It's wide. It's a really wide camera. Mm-hmm.
Alright, we'll do those later. you 40 viewers on my stream. How about you?
I have no idea. I'm not looking. Okay. So now we're back in the business here. This is Jeremy's booze. It's rubbing alcohol spray. Let's clean this lens.
I spray painted a lot of the brackets either silver or black to try to match the colors of Ultron. Worked out okay. I used Krylon plastic paint. I probably should have roughed them up before I spray painted them.
Okay, here we go, guys.
What a
So
bit.
finally, we got everything back together. So let's talk about the servo pliers. Okay, so this is the cable that they give you for the servos, right? And so what I did is I just cut it, and then I soldered onto the end a regular cable like this. It's got a female adapter on the end of it. And if you look at these little weird grooves, and there's a flat side on this back side here, with the weird grooves up, this furthest one is ground on the left, and then it's power. So I'll draw this on the board after I'm done. And then what I did is I took another cable, and its power goes to one connector on its own. But the other signal, I spliced it so it goes to another connector on its own as well. And you see I even cut off the power, the positive negative on this one, because there's no need for having power twice. So to connect this, you would hook it into your EZB, and it doesn't matter what order. Essentially, they're both going to be like shorted out, right? Like these two pins of D5 and D6. So if you find D5 and D6 on here, because one of them is receive and the other one's transmit. So essentially what we're doing is we're making the receive and transmit the same. Okay. So if I were to draw this on the board and show you, so what I've done is from the EZB, from D5 and D6, so what I've done here is connected the two together, the signal, so I'll put S here for signal, and that's the white wire, and then that connects to the, let's see, so if we look at the Dynamexel plug, and I'll try to do my best to draw in 3D here, so I'll go like this, and this is the side with the grooves in it, so it kind of looks like that, right?
Yeah, if anybody has any questions.
That's what the servo looks like from, and then this is the side that would plug into Dynamexel, so I'll just draw a big
When I see him.
servo here. Here's my awesome artwork, right? So on the, you want this to connected to this pin here on the Dynamexel, and then the center pin, connect that to positive, and then the last pin here, connect that to negative. Okay, so that's what I did. Here, I'll make this red for you. And to stick with colors will make the ground negative, black, there. Okay, so screenshot that, get an idea of how that connects. Okay. So back down to here. So I connected these to the EZB. And then what I'll do is, I just put you don't have to have this. Like I could have soldered this connector directly onto here. But the reason why I didn't solder it directly on is so that I can switch out different servos. So if you look at this cable, this is made for an AX12, and I made another one which is made for the Mini, for the XL320. So I can use this piece that's the same, and I can just swap out different servos. So plug this in, make sure you get your polarity right. Okay. Cool. And then connect it to your servo.
Alright. We got that full hot.
Cool. Okay, now we need some power. So I have a bench power supply. I would recommend using, is I think the AX12s. Let's take a look on the data sheet here. I'm pretty sure. See if I can I share my desktop with this? No, I cannot. I might have to go like this. I don't know if you guys can read that. Cool.
Alright. The servos are 90 degrees and see where they're at.
So let's type in AX12. Let's see if we can get a data sheet for that. Here's a data sheet for it. Voltage. So it wants between 9 and 12 volts, and it recommends 11.1. So you can use, well, how many cells, Jerf, to get 11.1 for the X12s? Can you use 4?
3 cells.
A 3-cell battery, yeah. Is that what they ship with the Mini or this thing, Biload? Yeah. So you want to find a 3-cell LiPo battery if you want to power. Yeah, it's 11 volts. So let's go back to our. There we go. So I'm going to turn on. I got this bench power supply next to my pizza. So I can specify exactly how much voltage I want. So I just set it for 11 volts. And we'll power up the EZB. Okay, so let me load up Easy Builder so that we can start showing you, and I can share my screen on Easy Builder. Let's do that. There we go.
From the previous hack has my battery port for the ROB.
All right. One sec. I gotta change the music. Alan, Jeremy's got me rocking out to like Van Halen or something right now.
Need more chill stuff?
No, I need more like bass.
Oh.
Speaker's actually quite terrible. Okay, so an easy builder. Let's do this. Doo-doo-doo. Okay, so this particular servo is on port 18. So we're going to go, first we're going to connect to the EZB. So we'll do it over Wi-Fi.
So that's how we put his armor on. When I 3D printed this stuff, but it definitely didn't fit on servo.
And we'll connect to the Dynamixel. So first I guess you want to see how to get the plugin for Dynamixel. So click Get Plugins. And then when you get onto the software page, drop down into Servo. And then go to Dynamixel. And then click Download this control. I don't think you guys can actually see what I'm doing because I'm sharing a different screen. Don't worry about it. So I downloaded the plugin. So we're going to add the Dynamixel control here. There we go. And we want to configure this control, so we hit the little gear button here. And we'll use the default baud rate because I know the AX12s use 1 megabit, so that's 1 with 6 zeros. And because this one I said is on port D18, we want to enable 18 in this list here. So we'll just scroll down to 18, click Enable, click. And the 18 uses Protocol 1. Some of the newer servos use Protocol 2. So you just have to look up and see which server you're using for which version. So we'll use Protocol 2 in a second when we get to the XL320. And now you see this note here. It says if any changes are performed on the settings tab, the save button must be pressed before using utilities. So you have to push save and then go back into it. And then we'll go to utilities tab. And in here we have our protocol version we're going to be testing with and manage our servo. So we're going to use servo 18. And then here I should be able to just move that servo. So it's moving. I'll hold on here. You guys couldn't actually see anything that I was just doing, could you? Interesting. It was there for a second, yeah. It's kind of bizarre, Will. Whenever I open up like another window, it just doesn't show up for you guys. I wonder why that is. This is going to be... I remember Perry S. last week is like, you should practice more, get stuff set up. And I'm like, no, I got a job to do. So this is this is for fun. So the only time I actually figure this out is when we're figuring it out together in real time. So I'm figuring out how to share my screen right now. And it seems like I can share this window, but I can't actually share the desktop.
Alright, we have the arms ready. Start working on the legs. We'll probably do that for last.
Yeah, well, I guess we get to figure this out together. All right. Let's see here. Boom, boom, boom. I wish I could share the screen that I'm working with and show you guys. This is bonkers.
I used to think this was called Red Hot Love. Red Hot Love. Well, it's radar, isn't it?
Yeah, it's radar love.
So many screens.
Okay, we'll do this for now so you guys can see that I'm trying to figure out how to share my screen. So maybe this is easier. that's a better way to do it. Can you see it like that, Will? They're learning step is steep. You know what? It's actually not hard to use, Will, for oh, it's just too hard to read, the text. How about that? Okay, so it's not, I mean, it's just a reflection of my screen a little bit too, so it's not going to be too easy to see. But with OBS, it's actually not bad, because in this left window here, it depends if you're inside of studio mode or not. But you just draw what you want the window to look like, right? So in this window, I have Easy Builder set up. If I delete Easy Builder, it's gone. But when I click Add, I get this button, Video Capture Device. And when I choose, or not Video Capture Device, sorry, Desktop Capture, this one here. But when I choose it, it shows me nothing. I read somewhere it might have something to do with the fact that I have a GPU as well. Because I know that this is, OBS is running on the GPU, so maybe it runs in a different thread. Oh well. Let's just work with what we got here. Okay, so hopefully you can see this enough. Yeah, you can see that enough. That'll be fine. Cool. Okay. So I'll close this control down and we'll go back and start from just fresh again. So click Add and then click on your Get Plugins button here in the bottom left. And this will bring you to the web page with all of the controls in Synthion. And you want to choose Servo, then choose Dynamixel. And then there are instructions in here, everything I'm going to cover, including like how to connect the wires with my really awesome Microsoft Paint artwork. So I click download this control, boom. And then when the control downloads in your bottom left, your browser, click on it. And it'll open up a window and you can push any key to close it. Now, if you try to update the control while the control is already added into Easy Builder, you're going to get an error message because it's already loaded, right? So you can't overwrite it. So you have to make sure the control is not on the screen if you're doing an update. So close it first and then update the control. So we'll click Add, and then we're going to go to Servo, and we'll choose Dynamixel. And then in here, you can click on the little gear to access the configuration. So starting from what I was saying earlier, the baud rate set for 1 million. So that's 1 with 6 zeros. And then you want to know the port that you're going to be using. So put this up here so you can see. There we go. The port that this servo is set for is 18. Okay. Now when you buy them, they're default set for, I think they're all set for like 1. So you have to change it yourself. You can do that either in our software or you can do it in their software. Okay, so because it's 18, I want to scroll down and I want to select 18 from the list here. And then the default positions that the servo uses, there's 1,024 of them, so we want to keep that because we're using the AX12.
No, Ben, this is the left leg.
And then the version that we're going to be using is a version protocol 1 because the AX12 uses protocol 1. And then we'll demonstrate protocol 2 with the XL320 in a second. So you'll see here it says if any changes need to be performed to this page, then you have to actually push the save button. So push the save button and go back to Windows. Okay. And then we can now go back into the Dynamixel again. This time we go to Utilities. And we can select our protocol 1, we can select 18, and then we can be able to move the servo. So Okay. Should also be able to push the ping button, and we should be able to ping the servo. Now the only reason why this is saying responded to ping, it's actually working, is because we have both the D5 and D6 on the EZB hooked together. And that means that we can send and receive off the single line. Okay, so that needs to be there. Now we can close this down. Now I'll show you how we're going to read positions from the software. So let's pretend that we have an auto positioner, and we'll add one. So we won't have to pretend, I guess. We'll just add one. Boom. Here's our auto position control, and we'll go into that, and we'll add a new servo. And we'll drag this over here, and we'll call this servo V18, because that's the port. Remember, it's 18, so virtual port 18. There we go. So now if I move this, I can move the servo. All right. And then what we'll do is we'll turn off port edit mode here, because we don't need to edit the port anymore. That means we can't move it around. We can't drag it. All we can do is move it. And then there's a button here called release all servos, so press that. And then it's going to say real-time update was checked. It's going to uncheck it, which is fine because we don't want it to move on its own, right? So now if I grab the servo, I can move it with my hands. Like this. Okay, and as I move it, I can record the position. So if I move it all the way down to this end here, right to there, I can push this button on the bottom left of the screen that says get all servo positions. When I push it, it's going to move this into the position, the number of degrees that the servo is currently set for. So I'll push it. There, it's set for 140. So now I'll take the servo and I'll bend it, move it all the way back this way, and I'll push the same button again. But this time I'm going to, rather than hitting the same button, I'm going to hit a new frame. This one's called stand 1, and now I'll click get all positions. So I got it. Now it's position 39. So I'll push new frame again, make another frame. I'll move this one halfway, like that. And I'll push get all positions. And then I'm going to push, or move this again, move it, say like halfway like that. And I'll push new frame. And I'll say get all positions. So I'll push that button again. So you can see. So each time I push it, I've now recorded the positions of each frame. So I can do this with a larger robot. We can move it around.
Some visitors here at Cynthia checking out some of the stuff we're doing.
Yeah, the plugin was updated earlier. There's, I think the lag you're getting is, I have it like on YouTube set for as low lag as possible, but we're also listening to yodeling rock and roll music. It's kind of annoying me. I'm turning it off. One sec. Jeremy's not allowed to make music anymore.
Come on.
We listened to last week.
Can't go wrong with classic rock.
You can when it's yodeling in the background. He was yodeling.
I didn't hear you yodeling.
Okay, so now that we've showed how to like move and get each servo position by hand, then you can create an action. And we can call this action my movement. And then we can add our frames to the left over here, to the right frame. So we go stand 1, stand 2, stand 3. And we click this action repeats and save it. So now when I hit my movement and hit execute, that's the little animation that we just created being played back.
I'll add the link to my project showcase of Voltron.
All right, okay. So that's with the Dynamexel using Protocol V1. Okay. So we can also do the same thing with Protocol V2. So I'll show you that. Okay, so this is AX12. This is the V1. So I'll push this off the side. And this is this little servo here uses protocol V2.
There we go.
So I'll plug this guy in.
That bends, alright.
Should I make these plugs very easy to work with here? There we go.
Won't be hitting that joint too much.
Okay, we'll do the same thing like this. And the configuration for V2 is going to be the same as with what we just saw.
Pretty decent. All we have to do is add the line at the bottom and we're good to go. Not exactly lined up perfectly, but it's decent enough there.
Yeah, the plugs are annoying, eh? They're pretty difficult to play with. Okay, so thing is, I can't actually chat with you while I have this open because there's no way to have like this window and this window at the same time. Maybe I should get myself like a screen that I can have up in the corner here where I can keep the chat window open for you guys. All right, so this servo, because I just picked it up, and the one that Dynamaxwell just sent me, the XL, this is an XL320. This servo by default, it says that it has ID 1, and we should also check and see what the rivets, where do you see rivets? On here, on the servo? So let's check out and see what the power is of this one, XL320 data sheet. Let's see if we can find it. There we go. It says here that the power is between 6 and 8.4 volts. Recommended 7.4. So I should probably turn my power supply down. At 7.4 volts.
Alright, we got the left leg complete. Guess we can mount it.
Yeah, 8.4 I think would be a little bit too high for this servo because it says because it says 8.4 is the highest, but I don't think I'd want to give it 8.4. I'd probably give it its recommended as 7.4. If you're trying to lift something that you need more power for and you're pushing the limits of the servo, I think I would recommend buying another servo because this little guy, I mean, it's plastic gears. It's not the greatest servo. It's actually pretty wobbly too. The spindle wobbles quite a bit. Okay, so because this is ID 1, what I'll do is I'll go back into the Dynamaxwell configuration, and I'm going to choose V1, and I'll click Enabled, and this is Protocol 2. So I'll set this for Protocol 2. And again, like this says here in this color, we have to push Save, click, and then back into here. And now we should be able to select V2 from this list, and V1, and I can move the servo. Okay, so what I'll do here is I'll save this, and we can do the same thing now with our auto position. So if we wanted, we can get into auto position here, and I can go click on my servo, and I can click port update, and I can change it from being D18 to V1. And we can run those same animations that we just created. So now I can click execute. And there we go. So if I wanted to read positions with this servo the same way we just had done with the other one, because it's plugged into the same cable with D5 and D6 hooked together, I can go into here and we'll just make another frame to demonstrate. And all I have to do is release the servo with the button down here. I can move it by hand now. And then what I'll do is I'll push the get and set all positions. And you can see it read the position 135 and I put it in here. So now I can go back into actions and I can add my stand number 4 to my action list. And I can double click on one of these stands and I can slow it down or speed it up. So some of these, and you can have a script run for each one. We'll click save. Now we can execute this. So I know that it looked pretty simple, and I think you guys are like, oh, that's what I did, but it's not working. Do you guys have any questions on what I just did to get this working? And also, Perry, if you think it's really lagged, there's a live button you can push in your browser when you're watching the video. It's here. It's right here in your bar. Make sure that you have that live button hit. Every now and then you might find that it unchecks and then you start lagging behind. Let me stop that. Okay, well, so why don't you tell me, what do you think? What are you doing that's not getting it to work? And I think EDP up here earlier said that he was using the X12s. Oh no, Marco C. Are you still here, Mark? Are you using the X12s? Do you have any issues connecting them?
Since the head is the last step of Voltron in the show, we're going to do that last.
All right, so the XL. Let's take a look at it here. So it uses a different connector, and I haven't actually used the XLs yet. Perry, you found that button and you regained the last 3 years of your life. That button really helps, especially with the chatting. YouTube should make it more clear. Oh yeah, Mark, if you only had D5, then it's only going to be transmitting one direction. Okay, so before we start diving into this servo to see how we can get this one working, I need to go grab a beer. I'll be right back.
You sure? No, I think I'm good, thank you. I'm gonna chip that. There's a warm room right there. That's fine.
What?
Alright, it's time for me to take over DJ's stream on this phone. Hey guys, good to see you.
Blue Moon. I know Perry S loves my beer selection. This episode is sponsored by Coors Banquet. Bring out the redneck in you. I'll have a few more of these. I'll get my redneck going. This camera keeps going crooked.
Oh no.
There we go. That's better. Now Jeremy's not crooked in the room. Look like one of those rooms from a science center where you're like, you go inside and half the room's crooked and the other half's like super small.
Yeah.
Yeah. Okay. Another bite of pizza and we'll figure this out.
Oh yeah, pizza. I should probably go grab some. It's still hot.
What? Hot?
Well, it's still semi-warm.
It was an hour ago the pizza showed up.
What? Has it been that long?
Mm-hmm.
No way.
It was 7:30.
That's crazy.
Robots and beer? You better. It's too bad we all couldn't stream, like do like a chat. Oh, hey, who wants to connect to the robot tonight and drive the robot around?
Oh yeah.
You guys can come visit us. First person to type me. I'll send you an invite.
Well, this guy's now locked you up. This one's moving a bit. This one won't. Alright. New
Well, somebody has to.
leg is done. Send them out with some robot.
All right, nobody's typing me, so we'll go with hacking the servo instead. Okay, so let's do the XL servo. This is the XL 430. So I think the first thing we should figure out on the XL 430 is what commands it uses and what protocol it uses. So let's do some Google searching. Yeah, well, we got telepresence robots. You want to try it? Ooh, our web developer just told me that he updated the website and there's a new editor now. Let's check it out. I don't know, we're about to find out. Let's see. What did he change? Oh, I know he changed something with your profile. So if you click on somebody, like let's go click on Nomad. And if I click on his name here, look at that. Brings me to all his posts. That's cool. And let's see. If you click on any of these, you should be able to see the editor. Oh, it's the old editor. He hasn't done the update yet. What was Amin talking about?
I don't know.
Maybe he said he was going to do it. He's going to do it soon. All right, we'll hold him to it. Okay, Will. Let me send you an email and I'll get you set up to the telepresence robot. Just gonna get your user info here, Will, one sec, so I can send you an email. I can't share my screen when I do this, otherwise you'll see our administration interface. I can see all your informations. There we go. Okay, Will, check your email. You should have gotten an email, and when you get it, you connect to it. You're going to be against the wall, so use the arrow keys on the screen and on your keyboard, sorry, and just hit backwards to back up against the wall, away from the wall. And then I'll guide you in. Actually, I won't guide you in. I'll let you explore and see if you can find find us in the building. I think I need to find a monitor.
Get your little tiny monitor over there for your VR.
No, it would be too small, I think. I wouldn't be able to see anything.
Yes. Alright. Got her. That's solid. Put the other side. Over.
Made the D5, D6 connector ping is working for the X12. Okay, so you're able to ping on the X12? Is that what you're saying? That you got it working, Marco?
Battery back here. DVD remote controller. Got a wire harness here. Probably assembling already. Put that together. And then we'll go for the challenge of cooking all the stuff. But before that, we do want to do the head. That'd be important. I think I might take a peek
Cool. That's awesome. That's good to know you got it working.
Still warm. That's about. Let that sit for a while. Perfect time for a break.
Waiting for Will to see if he connected to the robot yet. Doesn't seem like he has.
I'll be back in a few. Little bit of break. Here, I'll put his head over here so he can walk up the head. There we go. So he's gonna look like some. You know, we're gonna get the RGB LEDs in his eyes. And blink all kinds of colors. Let's go well.
Nice. I'm watching your old video.
It's actually laggy, like real laggy, man. It's probably like.
Did you click on the live button or you watching? You did?
I did.
Yeah. Nope. Yeah.
It's just super laggy for some reason.
When you set up your settings in YouTube, did you set it up to be real time?
Probably not.
Probably, or do you remember the option?
I didn't remember the option, so I probably didn't do it.
You didn't do it, yeah. There's under, it's like, you'll see next time. There's a button, like when you're configuring it, you can choose your stream to be real time, buffered, like there's 3 different options.
Oh, I remember those options, yeah.
Yeah.
I just kept the default, I don't know what it was.
Yeah, I set mine for real time. I don't know if you could change it now though. Let me see. Edit video. Advanced. Live.
Oh, I didn't think of it. You're back.
Yeah, you can't change it now, Jared.
Good.
Okay, this is a lot of fun just sitting around waiting for Will to check his email. So while he does, I'm just going to, I think I'm just going to start and play with this XL servo and see if we can get it working. Okay. Let me first start by getting the data sheet. Because I'm worried, I think before I check anything, I should check the plugin source code and make sure that, because I know this servo is using protocol 2, but we should check and make sure that they didn't change any of the commands and they have like a specialized version of the protocol or something. So let's do that first. So this is an XL430 W250T. Okay. So here's the Robotis e-manual. Robotis can do a lot more work on their manuals, that's for sure. Let's see. So voltage, operating voltage, whoa, it's quite the range. 6.5 volts to 12. That's pretty good. Recommended 11.1. Oh, that's really good to hear, Marco. Didn't take much, to do it? Once you get D6 hooked up, D5 and D6, you're off to the races. Okay, let's take a look at the protocol here. So, I got the plugin source code for the Dynamexel here, and let's check here and make sure that I'm not missing anything. So, communication speed. Baud rate. Initial value 1. What does that mean? What baud rate are you default set for? Oh, default baud rate is 9600 baud to 4.5. But what's the default baud rate though? Okay. Okay, so it says the baud rate is a number 1. Let's click on it and see what it brings us to. Will, you should get a faster internet connection. There we go. 57.6. Ugh, it's terrible. Okay, so 57.6. Let's try that. Well, trying a megabit's not going to help because you can see here if you read the data sheet, the default right here is 57.6. So setting it to a megabit is not going to help. So let's set it for, let's go into our control here, into our Dynamexel control. And I'm going to uncheck the other servos that we were dealing with. So V18 and V1. There we go. So this is probably set for port 1. It's protocol 2. And the default baud rate should be 57600. I'll click save. And now let's go back up. Let's take another look here. Okay, so I'm looking at here is, so these are all the commands in the datasheet. And the command we care for is the goal position. So goal position, where are you in this list? Okay, here we are. Here's goal PWM, goal velocity, goal position. There it is. Oh, interesting. It wants 4 bytes, or 4 bits. 4 bytes, I mean, sorry. I'm just thinking out loud and I'm making mistakes while I talk. Why does it want 4 bytes? So it's a 32-bit integer. Interesting. I'm only sending 2. And the memory position it wants is 116. Let's take a look at the source code for the Dynamexel plugin. Close this down. So Dynamexel V2. So in the source code here, we have a command called move servo. And it's sending the command 30 to move the servo, which is not the same command as 116. So it wants the memory address 116, we're sending it 30. So it looks like the XL series servos, they've changed, even though it's called protocol 2, they for some reason changed the protocol. Well, at least the command memory address of the protocol. So the protocol is probably still the same, but Memory address has changed. That's weird. Wonder why they would have done that. Okay, so here's what we'll do. Let's just comment this piece of code out for the time being, and let's put in the memory address they want, which is 116. Okay, and let's try running this again. Oh, and I also have to make a cable for this thing because I don't have it hooked up yet. So let's go back to the data sheet. Let's see if they actually have a diagram of the cables. Yeah, I don't know why they would do that, Will. It seems kind of strange that they would change the command set. Like all the other servos use the proper protocol too. More bizarre. I would just copy the wiring that I drew on the board, but who knows, maybe they changed that too. I don't want to damage the servo. Well, I guess it really wouldn't damage it, we just ground versus signal. Okay, let's make a cable. Let's do that first.
You didn't mess with my stream while I was away, did you?
I did, took off my clothes.
Oh, they're already disrespecting me that way.
Alright, let's find the connector that this thing uses. Oh, this is it here. Sweet. Looks like I was already starting to do this one because it's got some wires bared. This is pretty cool. I don't think you guys ever seen this before. But one of our old employees, Corey, I designed the first one and then he modified it and made this one. So it's got your flex or your tin here. So you can clean your solder head off, and then it's got the solder. It's pretty cool, eh?
I like to do that quite often. Hey, you'd make a design and be like, you know what, I can do one better.
Yeah, Corey would always take stuff I made and then change it. Okay, let me get another connector. Here we go. This is the connector we'll use.
So we get all this heat shrink off the wires. I could just cut it, but
Hey Will, if you want that design, I can send it to you. Remind me, ask me on the forum, just say, hey, send me that solder holder, and I'll put it up on the forum and post it, the SDL file. Although you could probably make it. Yeah, sure guys, I'll just put it up on the forum. Okay, so according to my wall drawing, let's see,
cut some heat shrink for these wires again. Don't forget.
I'm thinking that, I'm gonna guess that it's this way. We'll try it out first. We'll try it out first. Man, I wish they would just have a schematic on their webpage. What the heck, guys? Why don't you have a wiring schematic for your servos? Like, there's more details on how to plug it in than there is on how to actually wire it up.
We'll cut 8 pieces of heat shrink for both the LEDs.
Let me go back. wiring. I know it is something so critical. Like you'd think this would be the first thing they'd put, saying, "Hey, do you want to use the servo? Here's how you wire it up." They don't. I have to use Google to find something. Here, how about this? What's this page? Nope. It's kind of crazy the amount of times I have to actually Google and reverse engineer something. Like UB Tech, the Alpha 1 servos, when somebody posted and asking if we can get those working. And then, I can't remember who it was. I think it was Alan. I think he found and posted some link to an open source project that somebody had. I didn't want to actually do those servos. I was like, why am I going to support Alpha 1 servos? You can't even buy them individually. And once we got the information posted, I was just like, screw it. I might as well give it a shot. So these are the AX12s. Okay, well, tell you what. So let me show you this cable here for a second. Okay, so on a servo, you have your white, which is signal, then you have red, which is power, and you have your black, obviously, which is ground. So the way they designed these cables, which is really smart, is they put power in the middle, so it doesn't matter which way you put it in, you're not going to damage anything. Because you have ground on one side and signal on the other. And your signal is always like a TTL level, so it's not going to you're not going to damage anything if you ground it, right? So we could hook it up as long as we know we are confident that it's using the same standard that the rest of the world uses and the rest of their servos use. I'm only somewhat hesitant because they changed the communication protocol in this particular servo, so it makes me wonder if they would have changed the wiring. No, that would be weird, right?
How much is that servo weight?
This servo's like 300 and something bucks.
You want to be certain.
It's expensive. Well, we didn't buy it. They sent it to us, so I guess it's best that I test it out before any one of you, because this was a free servo to me. So what I'll do is I'll just solder power in the front and the middle, and then I'll solder the others temporarily, and we'll just yeah, we'll see what we end up with here. I'm kind of a cowboy solderer. You guys get to see how I work. Jeremy puts things on nice little holders and stuff, and
No, right now I'm not.
yeah, too.
Alright, we got all the wires free. Put the heat shrink on there. Then we'll prep the next LEDs.
Got my solder temperature set for 900 degrees.
Over 9,000.
Either way you plug it in, the LED flashes. Yeah, you know what? You're probably right. The LED is going to flash because it's most likely going to use the signal, because the signal wire is going to get some ground, and it's going to get enough ground off the signal wire to power itself. That's not uncommon to see. It just runs through the chip. So I'm going to make a guess based upon my schematic, though, that the top wire is ground.
I think I'm gonna modify these the quick way. I'll just use the Dremel. Keep them nice and flat so they can fit inside of those eyes there. See, they're a little bit too round.
Those eyes.
Those eyes. And I flattened the LED out by sanding it before.
Alright. Last thing we need to do is short these out, short out the EZB too, so I'll put some tape around. Okay, let's see if we got this right.
I'm gonna put some gloves on just in case. It's going up my fingers. Sorry to your viewers, DJ. It's gonna be loud for a little bit.
Alright guys, it's gonna be really loud for a second. Jeremy's doing some drilling, some dentistry. Okay, let me see if the light... Okay, light flashed. And let's go back into our software. I gotta figure out how to do the screen sharing on this thing. This is ridiculous. So add our Dynamixel. And we'll set the baud rate to 57600. V1 protocol 2. And V1 protocol 2. Okay. Oh, I didn't connect to an EZV. That usually helps. Let's do that. There we go. So protocol 2, port V1. Nothing's moving. Okay. So let's look back at our code for a second here.
It's a little bit big still.
We have it set for memory address 116, and according to not this file, let's see, the manual they gave us. See, as a goal position is 116, and it wants 4 bytes. Yeah, let's try spinning the connector first. Good call. So I'm doing that right now. Okay, I spanned the connector, light came on. Let's try this again. Let's go into our configuration, protocol, port 1, protocol 2. Yeah, nothing's happening. Okay, so one of two things that's happening here. We know that they changed the communication protocol because it's set for 113 or 116 for the goal address. They might, there's nothing in here about whether or not they changed the checksum or the CRC. So, but what is in here is it expects 32 bits, which is 4 bytes. So why don't we, now the voltage is at 7.4 volts. So, and it needs a minimal of 6.5. So it's not that, but what I'm thinking it might be is that I'm only sending 2 bytes, which is 16-bit integer. So what I'll do is 116, let's modify the code to do that. So this is the plugin. And if we get it working with this, then we'll just do is I'll modify the plugin and I'll add a second option so we can control these servos with it, with a different command set. So also we should check what the position is. Is it What's the value, the range? It's between 0 and what? Oh, 0 and 4095. Why would they have made it a 32-bit integer if it's only between 0 and 4095? That's strange. Okay, so let's modify the code and send. Shut this disconnect here from EasyB. Okay, so this is the Dynamixel command function that I created. So what I'll do is I had it hard coded for the length because you just pass in instruction, address, and value. So what I'll do is I'll change this from a 7 to a 9, because we'll add 2 values to it. Well, here, I'll just comment it out. And then instructions, and then I'll change the address line here from being a, not the address, sorry, from the value, from being, oh, we should check that too. Maybe the address it wants is a, make sure the address, no. Here, protocol 1 does not support addresses greater than 256. Therefore, indirect address can be accessed protocol 2. Do you know, Will, do you know if this is by default set for the protocol 1? I wonder how we find that out. Here we go, protocol version. EEPROM value 13, protocol version. It says the default initial value is a 2. I'm guessing 2 means protocol 2. Let's find out. Protocol version. Yeah, 2 means version 2. Okay. That's fine. So we'll assume that the address portion of the code, this part here, the instruction, is still an 8-bit value. Not the instruction, sorry, the address, this part here. So we'll keep that as a unsigned 16, and then the actual value, we'll make that an unsigned 32. And the rest should just work. Let's find out. So we'll compile this. And I'll add servo, Dynamixel. I'll make it 57600 baud rate. V1 protocol 2. Click save. I'm going to save this so we can recall it if we want to. I'll call it test Dynamixel. And I'm also just going to add a servo control here. Oops, wrong one. So we can test it right from here. I'll set the minimum value to 1, the maximum value to 180, and the port V1. There we go. Okay, we'll connect to this off to the EasyB, and okay, nothing's happening. Let's move. Let's turn this and flip this around. See what we get. Okay, the light flash. Let's try it again. Still nothing. V1 protocol 2. Let's see if the default ID here. Default ID is a 1. So we're sending the instruction address. Let's take a look at the code. What I'll do is we can go into our, we'll go into this piece of code here. This is where it goes to move the servo. This is get position, on release, servo speed. Here we go, servo move. So in servo move, this command right here should run. And we can see the data that it's going to actually want to write out. So I'll put a breakpoint here. And when I go back into the program, And if I just move this one position, it's going to run the break, launch the breakpoint, and you'll see here that it's going to get the ID and then move into the servo command. So we'll just pass step over this entirely. There. So now this variable, command data, will contain all the data that we want to transmit. So 255, 255, 253, that's the header. And then a 0, which is correct. And a 1, 9. So I think the 1 is the... I think it might pair to the header too. Let's find out. Oh, it's the ID. Okay, and then the next bit will be 9, which is the number of bytes, which is correct, right? So that'd be 1 byte, 2, 3, 4, 5, 6, 7, 8, 9. It's correct. And then the next byte after that would be a 0 because it's a 16-bit int. So 9 is Little Indian. So we'll get the Little Indian first before the Big Indian, like Gulliver Travels. And then 316, so that would be 3 is the that means write to a memory address. 116 is the memory address we're writing to. If we look into the data sheet, 116 is called goal position. And where are we here? There we go. And the next value here under 116 is a 0, which is correct because it's a 16-bit int. And then we have 182, 0, 0, 0, 0, 0. Okay, so we're saying 4 bytes for the address, for the location, like the physical movement position. One, 2, 3. Actually, no, it's only sending 3 bytes because the... Hold on here, guys. 116. 0. That's the memory address. And then we have 1, 2, 3, 4 bytes. But the checksum, I believe the checksum should be 2 bytes long. Let's take a look into here. So go up to the checksum. It returns an integer, an unsigned int 16. Yeah, okay. So we are right here. We're supposed to be getting 4 bytes from this and adding it. Why aren't we seeing 4 bytes? Let's take a look at this one more time. Oh, never mind. I didn't realize there was more. I can scroll. So it's 182, 1, 2, 3, 4. 1, 2, 3, 4. So that is correct. And the checksum is 21249. All right. So 255s, 0, and then a 1 for ID, 9 for the length. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, the length is actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How's that possible? I thought we were just only added 2 extra bytes to it. Oh, because I accidentally counted the 0 from the 9 because it was, like I said, like it's a 16-bit int. So I go from 9, then I go from the 0, so that's 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh man, interesting. Very interesting. Why are you not moving, servo? Why? Let's go back into the project here. Let's go back in here. So we initialize at 57.6, port V1, protocol 2, and we definitely are editing protocol 2. Here we are. And let's put a breakpoint. No, there's no point to put a breakpoint in here. try pinging the servo and see what kind of error we get. Protocol 2, V1, ping. Servo not responding. Makes sense. So I'm going to flip these wires around here and see if this makes a difference. Ping. Servo not responding. I'll take a look at this data sheet again. There's got to be something in here that we're missing. Okay, model, version of firmware, Dynamixel ID. By default, that's a 1. Okay, that's fine. That's what we're doing. Operating mode is a 3. And a 3 in operating mode means position control. Okay. Protocol version. Everyone always thinks they're like, oh man, you're into robotics. It must be so exciting. It's like, actually, I spent a lot more time doing this, trying to decipher what people are writing into data sheets. I feel like programming is the standard, right? Like, it's pretty, you can't program with, like, you get a syntax error if you write something in wrong, right? This doesn't compile, nothing works.
Yeah.
But document creation, there's no such thing as a syntax error.
Alright, have a good weekend, guys.
See you, man.
Good night.
Did you do the website update?
Yeah,
Oh, cool.
it's all
Nice.
up.
Awesome. Okay, so now it sounds like we have the website that's up. Let's go take a look. We'll take a break and check out what changes Amin made to the website. Or if he left us with a bunch of bugs and went home for the weekend. So I think first thing he said is we should be able to see a new editor. That didn't change. Oh yeah, look at that. Big buttons now. Now you can't miss that. Cool. Upload video. Source code. Cool. That's nice. And then he said something about if I click on someone's name, like I click on Perry S. Oh yeah, look at that. Now people's profile is different. Now you can see their robots, questions they've asked. You can see the behavior controls they made or apps. Cool. That's nice. We're spying on you, Perry.
Oh, did Will get the telepresence robot working?
No, Will couldn't connect to a telepresence robot because Will's internet is not good.
Oh, darn.
He said it kept timing out when he connected to it. I don't know why. Alright, let's click on Will's name. We can see all Will's information. Look at that. Here's the robots he made. Gargantua! How many? Here's all the questions Will's asked. 105. And no apps, no tutorials, nothing public anyway, other people can see. Cool. Yeah, he did do a nice job. Amin's pretty good at web development. We're moving him to a different role in the company though. He's going to be working on Easy Builder more, and then we're hiring somebody new for the website. But he's done a pretty good job at it. Okay, so back to this puzzle, the Dynamixel puzzle. Okay, XL430. What is wrong with you, Servo? Why don't you like me?
Okay, one down.
Okay,
There we go.
let's read this here. Control table. So the control table is a structure that consists of multiple data fields, blah, 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 to control things, blah, 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 blah. Well, that's a lot of text. Access. The control table has two different properties. Read-write stands for read-write. Yeah, we get that. So write means 3. Okay, initial value. Get your control. Yeah, we get that too. Okay, the size data varies from 1 to 4 bytes depending on their usage. Please check the size of data when updating data
Should probably test this one.
on the instruction packet.
I'll build the other one first. We'll test them together.
We can try to turn the LED on and off. I said the same thing, Servo. Why do you hate me? Yeah. I don't know. I'm going to have nightmares on this Servo. Okay, so to turn the LED on off, it wants value 65, and it only takes 1 byte. So that one we can at least test with. That's an easy one. So let's go back into our Dynamexel version 2 here. And let's find LED command. LED. There it is. Okay, so LED has, it sends ID. The number 3 here means that it's writing data. And then the next number is the address it's writing to in memory of the servo. In this case, it wants 25, which is wrong because Dynamexel, a Robotus, changed the address from 25 to 65. So let's copy 65 and put that in there. And the status is either a 0 or 1. That's easy enough. Okay, so let's take a look at the code and see here, make sure. I think we should be able to still send 4 bytes, but because the value is going to be here, let's send what we know works. Let's send this back to 16. Okay, build the project, load this up, connect to the EZB, go into our configuration, and protocol V2, port V1, LED. LED is not working. Okay, let's turn our connector around. What is wrong with you, Servo? Okay. So we know it wants 1 byte. We are sending it 2 because it's an int 16. I know this works on. Let me just think for a second, guys. Okay, let's bring this down from 7 to 6, and then rather this value being an int 16, let's set it for just a byte. So we'll just go like this, byte there. No, add range, add. Yeah, okay. And that should be enough. Okay, so we're officially sending 1 byte. Let's just count to make sure. So we said we're sending it a length of 6. It's getting 1 instruction, 2 address. So 1, 2, 3, 4, 5, 6, including the CRC. So we'll connect to it. Protocol 2. Alright. Nothing's happening. Let's change the port. Oh, look at this. unplugging and plugging this in, this fell out. So that doesn't help us too much now, does it? Ugh. Get this back in there. All right. It's not really fitting very well. It's bent too. Okay, let's try this. The ground's coming out too. For some reason this plug is not happy. It's not happy. I wonder why. It'd be a shame if we found out this whole time. It might have been working partially. Look at this.
You got it?
I got an LED flashing.
Nice.
Okay, so we got the wiring hooked up the right way, and ironically, the way I guessed was the right way. So that's good.
Okay, let's see.
Cool, 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 cool. Okay, Will, I did get an LED to flash. So if you're happy with just that, I can stop. Shut her down for the night. Go play some Galaga.
It's working. Okay, let's try the other ones.
Okay, so here's what I'll do. So we know that it wanted 1 byte. We got 1 byte sent. It was happy. Let's now try to figure out how we can make it move. Because I know for certain it's not going to move.
Alright, let's see. We got green, and let's hope we got red. There we go, red. Excellent.
Okay. Cool, cool, cool. We're close. Thanks, man. Yeah, we are getting somewhere. Okay. So, the only thing that we're not getting somewhere on is... I have to think for a second.
Four choices of color, and then selected black. You call an anode, and on the cathode is just black, on the anode it's colored red. It's not bad. Yes, this is great.
Okay, so here's what I'm going to do. I'm going to create another function here called create dynamixel command. It accepts a byte rather than an int. So, and I don't want this int to even be an int. I'm going to make this int. Oh no, that's... Just think for a second here. No, I'm gonna... Because if you send... I was gonna make it so it could be dynamic, but you never want to accidentally send... No. Okay, here's what I'll do. Is it a script you're writing, a plugin, or EasyV code? This is a plugin, Perry. So this is the code for the plugin, the Dynamexel plugin.
Alright, I think we have those positioned pretty good.
So this is what I'm gonna do. I'm gonna create a copy of this command, and I'm gonna call it create Dynamexel command uint 32, and I'm gonna create another one called
Alright,
byte.
that's about blue.
Create Dynamexel command byte. There. So this input value will be a byte, and this input value will be a uint 32. Actually, it can be an int. Doesn't even matter. And then
Far out.
so create Dynamexel command with byte. This is going to send 6, a length of 6. The address is still an int. That's a byte. I don't have to cast that as a byte anymore. Just making sure you guys can actually see what I'm doing. Maybe I'll make this little window smaller over here. There. That's better. Okay, so in a byte, so just make sure we'll count. So this here is the length, right? This is the length of the packet, and we want it to be 6, so let's just count. So we got 1 instruction byte, 2 address bytes, which is 3, 1 value byte, which is 4, and then 2 bytes from the CRC, which is 5 and 6, so that's correct. This one is called send a command uint32, and we're going to want, remember if this is 6, sending 1 byte, we're going to want to send 9, right, for 4 bytes. So let's change this to a 9. And the instruction's 1. The address is correct. And then we want to change this from add to add range. Use the bit converter, get bytes, and make it a uint32. And we'll get the value. There we go. And then it creates a array. So we want to count the bytes. So we have a 9 length, so it says instruction is 1, 2, 3, 4, 5, 6, 7, and then 8, 9, including the CRC header. That's good. Now let's go back to our regular create Dynamexel command, which is value. So I feel like what we're going to end up having to do is create, you know how like right now you can choose a protocol V1 or V2? We're going to have to make it so you can choose protocol V1, V2, and like a different one for each servo. It's annoying. Okay, so create Dynamexel command, this one just takes a regular integer, and this will be a uint 16. And it'll be 7 bytes for a length. And we'll put this back to value.
Anybody see my Voltron's head at all?
Did you lose your head? How'd you lose a head?
Oh, there it is.
Oh,
It's on his shoulder.
All right.
I found it.
And now our LED that we were trying to flash. Okay, so let's now make a servo move with this particular control first. If we can make it move with this, then we can do a complete copy. So let's go back down to our move. Where is it here? There it is, move command. So move command wants a 116. Let's check out the data sheet just to make sure again. 116 goal position, yes. And it wants 4 bytes because you're ridiculous and you're inconsistent. Where? I clicked on it to view. Oh, there we are, goal position. So target position can be set with goal position 116. From the front view of the Dynamexels, blah, 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 who cares? So the value is between 0 and 4095. It really doesn't matter. We're just going to send it a value between 0 and whatever we have it set for right now, 1024. Okay. But it wants 4 bytes. You're crazy. You're so crazy. Okay, let's do it. So we created a new function here called create uint32, which would do 4 bytes. And we'll send it ID 3116 and a position. And we'll go into that variable or that function just to make sure. We'll walk through it. So it's 9. We're going to do this one more time. We'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. All right, guys, let's give it a shot. Oh, I'm going to exit out of here one sec. We have to go back in and find the LED function, this one here, because we're sending it, currently it's using the regular one, which sends a unsigned integer of 2 bytes. What we really want to do is want to change this from create Dynamexel command into create Dynamexel byte, right? That way we can at least test to make sure that our, and we want to make this a byte. So we'll just go like this, byte. There we go. So we just want to make sure the LED still flashes so that we know it works. Fingers crossed. Oh, Perry, I answered your question if you missed it. I'm editing the plugin for the Dynamexel control. So this is, what I was doing is this is actually how you make a plugin. That's the code, the plugin code. Okay, so we'll connect to EasyB, and we'll go into utilities, and we'll select protocol version 2, and we'll turn the LED on and off. Okay, the LED is working, and the servo is not working. And ping. Whoa, dude. V1 responded to ping. Do you see that? Okay. So that's good. That means we're responding to a ping. So if I change this, for example, from V1 to V2 and I push ping, it says servo not responding. But if I put it back to V1 again and push ping, it's responding. So when I move the servo, it's not moving. I'm going to try turning the power up a little bit. Let's see if we need to give it more voltage. Let's give it 10 volts. Okay, we're at 10. All right, nothing's happening. Let's cycle the power. You think if it was a voltage alarm, we would have a flash of some sort. Okay, make sure the LED works. Okay. Nothing is happening. And it's getting 10 volts. It's not warm. The LED is working. And I can't really move. I'm trying to see if I can move this. Man, it's hard to move. I don't think they would have given me a damaged servo, do you? Try 11.1? Okay. I'll bring it up to 11.1. There we go, we're 11.1 now. Let's try this. No. Oh, it's getting warm at 11.1. Okay, I'm gonna bring it back down to 10. Okay. So it's responding to ping. We can move it. We can turn the LED back on and off. So something is goofy with our command that we're sending it. I have 3 servos that don't respond. Like they don't respond to anything? Interesting enough though, the servo is drawing 3.2 watts, 0.3 amps right now. Just sitting there, it's drawing quite a bit of current. If I bring it down to 7 volts, it doesn't change how many amps it's drawing. Of course, just the watts, of course. It's a pretty hungry little servo. Because the Easy B's drawing 1.1 amp. And this thing on its own, without doing anything, is drawing 0.25 amps. Did you know this, Jack? This servo, just not doing anything at all, is drawing more than twice as much as the Easy B. Wow. All right. Well, my beer is running out. Okay. Yeah, I'm getting similar volts. When the LED is blinking, does that mean the servo goes in safe mode? No, I'm blinking the LED by hand. If the LED does blink, though, it starts blinking rapidly on its own. That's because there's an alarm. But when I just do, oops, if I just do this, I'm blinking it myself. That was just me playing around. But I should be able to move the servo. That's what I cannot do. But I can ping it, and that's the part that I think is very exciting, because it means that we're talking to it. So let's examine the code that we're sending. So we're going to go back into this piece of the code, and this is where we assemble the command before we write the command to the servo. So I'm going to put a breakpoint here, and oops, then when I run and try to move the servo, let's just make a script here. Oh, we can flash the LED with a control command too, right? So let's move the servo. Servo V1, we'll move it to position 90. When I run this, it should launch that breakpoint that we put in code. So I'll click start. There we go. Okay. So what we're going to see is our header, 255, 255, 253, a 0, and then, let me see. Okay, so 255, 255, 253, a 0, then a 1, which is our ID, a 9, which is the number of bytes. And let's just count to make sure we have 9, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, right. We have to count after the 0 of 9 because it's an integer 16 just 2 bytes. So it's 9, 0, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And the 3 that we have here, that 3 is right. And the 116, that's the address we're writing to, which if we check the data sheet, 116 is the goal position, so it's a target position value that we want to move to. and then, which is 4 bytes long, and then we have 116. So 116 is has a 0 at the end of it because it's a 2 bits or 2 bytes, and then we have 252 and a 1, and that's because of the position we're trying to move it into, which is, in fact, we can actually make this a lot easier. Let's just go back in Easy Builder and change this from moving to position 90 to position 1. And let's do this again. Start. Look at the data. The reason why I did this is because now we see all these zeros, and we see a 225 and a 9. So we just told it to move into position 0. And now let's move this to from a 1 to a 2. Run it again and see. Okay, now I told it to move into position 5. And you can tell, here's how I can tell, is because the 116 that's here, that 116 is in the 0 beneath it. That's the address we're writing to. And then the 5 is the first byte of the unsigned integer 32. So of course it's 32. There needs to be 4 bytes in that. So it's 5. 1, 2, 3, or 4 bytes in that. So it should be 4. Okay, let's look at the data sheet and see if there's another command we should be sending. Instead of goal position, let's see here. So we have this thing called operating mode. We looked at that earlier. An operating mode is a default value is a 3, which is position. This mode controls position. This mode is identical to joint mode from existing Dynamexels. Operation position is limited between max and min. This mode is ideal for articulated robots that rotate less than 360 degrees. That's what we want. Okay, let's go back up. What other values do we have in here that we might have to change? Drive mode is a 0. That should be right. Drive mode is when the servo will go 360 degrees, just keep spinning around. So, oh, drive mode is not that, actually. Drive mode is what direction it goes, whether it goes counterclockwise or clockwise. So that value doesn't matter. We don't have to change that. Let's see what else we have here. Moving threshold, velocity threshold for moving, home offset protocol, PWM limit, we don't want that, maximum velocity, max position limit, that's 4096, that gives us our 4096 positions. Torque enable, the default value of torque enable is a 0. Hold on here, that doesn't sound right. Oh, torque, motor torque on or off. And the value is a 0. Let's take a look inside of there.
Okay.
Torque enable. Controls torque on or off. Writing 1 to this address will turn on torque and all data in the EEPROM will be protected. 0, torque off. Free run. The motor does not generate torque. Torque on. Okay, so then it says present position 132 can be reset when operating mode 1 and 11, torque to 64 updated. For details, refer to homing, offset, and present position. I wonder if we're supposed to turn that on. You think it would turn on itself, right? Like by default, it's not holding torque. 64. Well, doesn't hurt to try. So value 64. It wants 1 byte, which is a 0 or 1, and we'll send it a 1, which is turn it on. So let's do it. Let's go back in our code here. Actually, I'll save this project because we added this new script for testing. Alright, so go back in Dynamixel and we'll find the command for moving the servo. Move servo command. Where are you? There you are. So what we'll do is, before moving the servo, we will also create a command. So we'll just create a list of bytes. We'll call it temp list. And then we're going to add temp list, add range. We'll add this. And we'll return temp list to array. And we'll temp list, add range. And we'll create Dynamixel byte. And it'll be ID 3. And what was it again? Torque enable 64. We'll set it to a 1. Okay, let's try that. So when I try to move it into a servo position, it's going to automatically enable its torque. So here we go. Connect. Let's try this out. So what I'll do is just to make sure that we know that the servo is actually working, let's flash the servo a couple times. So I'll just put a piece of code in here just to turn the servo. The light on, sleep for a short period of time, the light off, sleep for a period of time. I'll just loop this. There we go. Okay. So I'll save this. Let's test this out. Oops, what am I missing here? It says error line 1, missing string quotes or valid expression. Boom, boom, boom. True. Oh, I think I'm supposed to put port in quote. All these in quotes, right? Oh, port is the port. Duh. I don't have to put that in quotes at all. Port is V1. 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 I could have just put this inside of a for loop, but this is fine. Save this. Okay. Do it. Here we go. Okay, we flash. We got our breakpoint that we stopped at, which is fine. We have lots of data in there. Let's just run past it. Okay, so is it holding position? Oh, it is. Boy, is it ever holding position. It is not. Yeah. Okay, so we turned on torque. Okay, guys. So it doesn't quite help us though, because we can now tell it to torque itself. We just can't tell it what position we want it to go into. All right, so let's keep reading the data sheet here. So torque enabled. Here's position gain, the gain of each position. We don't care about those. Bus watch, target PWM, goal velocity. Target PWM value. Target velocity value, profile acceleration, profile velocity. So goal position, this is the one we've been setting, 116. Real-time kick, moving status, present PWM, present load, present position is 132. Oops. Oops. Input voltage, temperature.
Eyes are online. They're working.
I wonder if we should try, rather than goal position, what's this goal PWM? Let's read what this means. Where is it? Goal PWM. In case of PWM control mode, for PID controller and feed forward controller are deactivated, while goal PWM value 100 value is directly controlling the motor through an inverter. This value is used to limit PWM value. Nope. Gold PW is not the command we want to use. Yeah, I'm definitely communicating with it. I mean, the fact that I can ping it, Will, is, I mean, it's good. It makes me feel good. I just don't know why it's not moving. It's so weird.
Also, can double check.
Let's see. So we got enough voltage for sure. And when I try to move it, because we have the torque enabled right now, like my power supply is just like going up crazy when I try to move it. So it's definitely, the torque is engaged. Why are you not moving positions? Well, this is nice. Current site will be maintained until 2018. Control table. Four bytes. Goal position. Goal position. 4 bytes. All right. What if we're just getting crazy here? What if maybe it's not an unsigned int 32? What if by chance it doesn't matter though? It's up to it to turn on. What if it's like an int 32? And it it doesn't make a difference. V1. Yeah, it doesn't do anything different. It flashes the LED. We're not moving into different positions. Should do those. I should save this project and close this down. I should go back into that move command we had, where I made it turn the torque on. Right here. Let's take this away because we definitely don't need to turn the torque on anymore. So let's just do this. There we go. 116. So ID 3 116 position. 4 bytes. We're sending it 4 bytes. Okay, here's what I'm going to try doing. Let's take the model number. Let's see if anybody else has ever on the internet tried to connect and control this thing using like an Arduino or something. I can't stand going through Arduino code though. It's like written by people who've never seen code before. It's like the caveman drawings of coding. Oops. XL430. That was rare, right? Did you see that? Your search did not return any documents? Like, how rare is it that you type in something so wrong that even Google doesn't know what you're looking for? They usually suggest, like, you can type in anything and Google will suggest. I could probably bash the keyboard and Google will suggest something. Nope, I'm wrong. What if I put like V2 at the end of it? No. Too funny. I'm impressing myself with my ability to not be functioning today. Let's go. Let's look at the datasheet again. And let's grab some text from the datasheet. So let's grab this goal position and 116. And that will give us some context in our search here. So goal underscore position.
So we'll get aside.
And we'll put the number 116 in there. Oh, here's some code here in a GitHub for the servo, the 43250. Released in 2018, it says. This product has been discontinued.
Alright, that's better.
Okay. Content of EEPROM area. Wouldn't that be crazy if they screwed up the documentation and we were sending data to the wrong port this whole time? Wrong memory address? Okay, so here's the EEPROM data, which looks fine. And here's the RAM, and this is what we care about because in here will be the goal position, which is, again, it's 116. Min position limit, max position limit. Oh, Jeremy got his robot moving in the other channel if you wanted to check it out on his stream.
Yeah, it's working now.
Cool, Jer.
You need to wrap these wires though.
Okay, real time, moving. What's this moving? Control table moving status. Well, this is not a very helpful document.
These two.
Hmm, 116. Goal, present position, goal position. Okay, that document is not helpful. Oh, this guy is having some things. He says, can't write word to change position. There are 8 of them connecting serial, blah, 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 blah.
Back to defending or
He says he can't move servo positions. He says doesn't matter what value you send, it's not working. And this guy is having the same problem as us. And they say, go ask in the Robotis forum, don't ask here.
Oh, sorry.
Oh, this guy says something interesting. JDS. He recognized, he says, from many of the fields, like goal position, are 4 bytes in length, not 2 bytes. So it's true, they changed it, right? So what do you mean by goal position not like in the updates? I know 4 bytes. I've tried writing a ton of different values, including just regular integers from 0 to 4,000, and hex values, and nothing, and no motions. And this guy says, with Dynamics SDK, you need to know if you're working with Protocol 1 or Protocol 2. In your case, Protocol 2. That's correct. We know that. And yeah, see, they made a function in here called write 4-byte TXRX inside of their packet handler, this thing called packet handler. So they themselves set themselves up for failure when they, I don't know, why would they want 4 bytes? It doesn't make any sense because a 2-byte value, right, an int 16, gives you way more than you actually need.
So what's been in the shoebox where
Right, so this is 2 bytes, 16 bits,
finally
which gives you 65,535, right? Everyone knows of 65,536 positions. When they add, you know, they add 32 bytes or bits to it, right? So, oops, so that's 16, and then another 1, 2, 3, 4, 5, 6, 7, 8. And this is the number of positions with a 32-bit integer that they would expect it to move into. So that's, just to be clear, that's 4.2 or 4.3 billion positions. Why would they have made it into a 32-bit integer is beyond me. So they broke like everything they've done so far just with this, made it very difficult to work with. So the Dynamux Workbench library, ignore differences in protocol, protocol 1, blah, 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 doesn't matter. This guy's like, I'll try by porting everything to Arduino first. Yeah, as soon as someone says, I'm going to port everything to Arduino, that's like when I hear people in the forum say, hey, I'm going to start using ROS. It's like, yeah, I'll see you next week when you've given up. Let's see here. Right word. Yeah, I don't know why they made it so big. Like, so just setting it up to 32 bits is just, I mean, that's only one of the two problems we're dealing with here, right? Clearly we're writing 32 bits. We can see that when we, here, we'll just go back in here and we'll put a breakpoint into our,
So
the data that we write to the servo.
Design files from a guy named Yuri.
Oops, do this again.
I don't know how to pronounce his last name very well, but he's also goes by 3D Workbench. He's the guy that originally
Why is this saying
made
no?
these files. They were free.
No symbols are loaded for this. Why not? Oh, because I haven't loaded it yet. There we go. So if I click start, oops, I'm not connected to an EasyB. There we go. Click start. We break this breakpoint here. We look at the data, and we are sending the position. There it is, 5000. That's 4 bytes, which is 32. So confused. I don't know. This is their affordable servo at $50. I'm interested to see if you can get the OpenCR board to get the servo works. This OpenCR doesn't really help us because it's just a bunch of Arduino code, right? And whoa! The servo moved.
Oh,
The servo moved. Why did the servo move? Why did you move? Move again. That was unexpected. Okay, hold on. Let's go back in here. Let's set this for port V1. Okay, let's turn this off. The servo's moving. I don't know what caused this. I seriously have absolutely no explanation for what's happening right now because we've been working with the same piece of code. Look at that. The servo's working. I can move the servo. Yes.
Just magically started working.
I can magically move a servo. Why can I magically move you?
It's Lucky Charms servo. Alright. There we go.
You are controlling it remotely to freak me out. Yeah, yeah, right, Perry. Mark, I have no idea how it just started working. I don't have an explanation for anything that's happening right now. The ghost in the machine, I don't know. Did I say something that made it laugh and think, oh, this guy deserves to have a servo working? The servo gods are looking down upon us.
There's a stuck bit.
Okay.
Stuck bit.
Let's, before we get super excited here, guys, let's shut down Easy Builder. Let's unplug the servo.
Alright.
Okay. Let's plug the servo back in. The light flashed. Let's load up Easy Builder again. And let's test Dynamexel. Click connect. And then move the servo. Okay, the servo is not moving now. Okay, let's run our script, which flashes the LED, and move the servo. The servo is not moving. Got to sacrifice a chicken? I don't know, man. I think you have to sacrifice an Arduino.
There's a board right there.
Okay. Okay. So the servo stopped working. It's not happy with us. Okay. Here's what I think. The only difference between what we were doing that started making it work was we had that 1-bit set called enable torque. I don't want to get out of here. Jeremy brought me an Arduino to sacrifice. Okay. You know, I've been trying to port EasyB, like some firmware, to an Arduino, so we can get, you know, like Arduino doing some stuff and be compatible with Easy Builder for those who, I don't know, are sick and tired of flashing LEDs with an Arduino. But the problem is, like, there's no standard. There's no standard with an Arduino. You can't say there's this many ports for servos or this many ports for analog, and there's no way to connect stuff to an Arduino. You have like all these female pins and you have to like plug everything in. It's a nightmare. Like, why hasn't anyone thought this is a robot controller? Plug stuff into it. It works. Like, I don't know, every other board you get is like just like this, just a bunch of pins. What are you supposed to do with this? Just a bunch of pins. I don't understand. Sorry, I'm gonna go on a rant right now, but man. Okay, so let's go back to why
Sword chop action.
this ain't working. So here's what I think. My gut feeling is the reason why the server was moving was because we enabled that torque value. So let's do something. Let's make it so that the torque value, the enabled
Still
torque,
there. He's alive.
is
He's alive.
a command.
Hold his-
Let's make it a control command.
Got a little bit too much bounce in his step.
So let's just try this for the time being. So let's go public, static, read-only, string, enable
Yeah.
torque.
This is what you're supposed to do.
There we go.
Sorry about all the noise on your channel, DJ.
And let's create a control command here. Oops, this is the wrong one. We'll call this commands, add, torque, enable, and then the port.
Let's see what's going on here.
And then when it receives a control command,
Oh, I think I know what happened. Yeah, I adjusted the.
let's
adjusted
copy this
serial
piece of code here.
configuration.
We'll call this enable torque. Right, is that what we called it? Torque enable? Torque enable. Okay, we want to pass one parameter, which is the port. We want to grab the port, and then that's it. It's the only parameter we care about. And if protocol 2,
Okay, now
we'll create a
let's mess around.
new function here called torque enable.
I'm gonna bring this in so you can kind of see the screen and what.
And we'll make it, yeah, we'll accept the status for the time being.
Easy builder.
And torque enable, what was the,
These are his wings. I'll put them
doo-doo-doo.
on a little bit
Let's
here.
see, do you remember what the number was for it? Was it 64? Torque enable 64, yes it was.
Get some of this stuff out of the way. We don't need it anymore.
LED 64. Okay, so status torque enable is a 1. All right,
Yes. So nice to see Voltron.
so we'll change this to torque enable and the status. Actually, let's have it pass a true or false, because let's test to see if we can turn it on and off. So let's go You expect two parameters.
Looking as yellow orangey.
There we go. Status.
So,
Get
I'm
port.
gonna try to make him have a walking gait.
Utility get ID from servo. Status.
Sure he's
Okay.
solid before we start trying to walk.
Let's run it. Here we go. So what we should do now is we should be able to run a control command which will enable torque.
Okay.
So I'll connect here.
Let's stand.
Okay. Let's just for fun run this and make sure that we're not crazy. Okay, we cannot move a servo. That's fine. Let's go into our script and then we'll run a control command we'll put here that we just created called torque enable. There it is there. And
Okay.
want to turn it on.
Walk one.
Save. Before I forget, let's get out of here. Inside of the control command code where it shows you the control commands that are available, right here, we didn't put true or false. There we go. Let's do this again. So we go into our, we connect to it, go into our script, and our script says Dynamexel torque enable port, turn it on to true, and then move the servo to position 1, or to position 2. Here we go. So flash, and we got an error message, invalid index. Oh, port, we forgot to put the port in there again. V1. I don't know how to use my own program. All right, here we go. So flash, doom, 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 and we can move the servo. There we go, guys. We're moving a servo. Okay, now we're not moving it very far because we're only going to 180. So let's go into Dynamexel control, and let's update this minimal max position value. It's set for 1024. It wants to be 4095. Click save. Okay, now let's try it.
I've never done a walking gait with hips before, so it's new territory.
Oh my god. I need a beer. I'll be right back. I got it working.
Nice.
Yeah, it's a nightmare though. It's like no other servo ever. Beer will help.
Good times. Good times. Alright. Let's make a new frame. Walk 2. And let's start. Alright. Seems like it's in the air.
Okay, so yeah, thanks Perry. Thanks Marco. I did get it, but I don't feel happy about the solution right now because you have to send a control command to turn the torque on. I'm thinking to myself, like, that seems like such a silly, like a really silly solution. Maybe what we'll end up doing is, because here's what's going to happen. It's not right now. If I can't publish the plugin, obviously, because what we did is in a V2 Dynamexel command, the commands are different based upon the type of servo you're using. For example, if I ran this right now against the other V2 servo, it's just not going to work because it expects a different memory address, right? 25 versus 65 with the XL servo wants. So I'm going to have to create a new protocol definition, which is going to have different byte values as well, because it's difference between UNT32 and UNT16s. You know what? Let's try something. Let's get crazy here, guys. Let me shut this down. First, let me save this project. Okay. Let's try sending the servo position as a 16-bit, so 2 bytes. All right. I wonder if it'll still accept it. I wonder if it needs it to be Because if it does take it, then I might be able to make it work with much less effort than I'm hoping. So I'm just going to turn this from a command uint to just a command. Okay, this is going to send a 16 bit value. Let's run this. So we'll connect to the Dynamic the EasyB, and then we'll run our script, which is going to flash the servo. Okay. So no, I cannot move a servo with a 16-bit value. It has to be a 32-bit value. So let's put this code back. Here's what's going to end up happening. I'll modify the plugin. It won't take much effort. I wasn't hoping to have to waste this much time on or spend this much time on this today. It's not wasted because we figured it out. But in the config, you can specify between two different protocols. Right? You can choose protocol 1 or protocol 2 from the drop down here. What's going to end up happening is I'm going to have to put either the servos in there or a second drop down which tells you what servo you're using in that protocol. Just thinking about it, I think it makes sense to put the servo in there. So I'm going to change it from being a version to being the servo. So I'll have, just to be clear, what'll end up happening is the drop down is going to say, rather than saying version, it's going to say servo. So you'll be able to choose the XL series, because I'm sure the XL series uses the same protocol for all of them. You'll be able to choose an AX12 because we know that that's the same, and you'll be able to choose an XL320. So those are the ones I have right now to test with. Dynamixel Robotis also sent me this one, which is the it's hard to read in the camera because of reflection, but it's a XH430. And given that I think it comes default set for RS485 or whatever it is. I don't think I'm going to have a fun time with this one. So as long as none of you guys are using the servo, I'm just going to throw it in the corner for the time being. But I tell you, if anyone is using the servo, I kind of feel bad for you because check this out. It's you have to go XH430 W350R. Let's go to Robot Shop's website and say we want to buy one. Okay, look at this. Oops. They're $305 US for this servo. $305 for a servo for this. Like, what does it do? Will it keep me warm at night? Like, why is it so expensive? I don't get it. If you guys know, let me know.
It's hard to walk with these two pieces here.
That's crazy. So here's what I'm going to do. I'll modify the plugin to do what I told you it'll do, and I'll release that this weekend. You guys can start controlling caviar. Yeah, we can grind it up to caviar, Perry. I think we'd have better luck grinding this up and making gold rings out of it or something. like I like Robotis. I think they're an amazing company. Their servos are remarkable, like truly are. I love using their servos. We've done a really good job with ours, but ours are PWM hobby servos. And given the fact that we were working with such a difficult signal coming in, and we did some really untraditional things that made the servos pretty remarkable. But we mass ship servos, right? Robotis ships how many thousands of servos a year? We ship, hundreds of thousands of servos a month. It's a different volume of scale, and Oh, Perry, you missed the verdict? Doesn't seem good. No, the verdict is good. We figured it out. It's just I'm trying to think of the solution on how to make it work. So Perry, to catch you up, here's what I had to do. We had to make a new control command. Here, I'll actually show you on the computer.
Glue this down here a little further.
So we made a new control command for the Dynamexel plugin called torque enable. And you can turn on the torque, and when you do, I'll show you here, you can now move a servo. See? But more so than just moving the servo, we also had to modify the communication protocol, the memory addresses that the other standard servo that we were using was specified. So maybe what Robotis has done is they said each servo has different memory addresses. That just doesn't really make sense to me, but that's just the way they did it, so that's fine. Well, it's not fine because that means you have to rewrite a bunch of code. So I was expecting when somebody says this is a communication protocol, they mean communication protocol. But in their sense, they were saying this is the protocol and how we transfer communication, but the memory addresses is a different data sheet. So they don't really have a protocol per se, they have a data structure for sending data. So they really should rename their document from data protocol to data structure. And then the how their data is structured. And then internally, the protocol, which is the commands that it should be receiving and transmitting, they're not universal across any devices with using the same protocol. Oh well, whatever. At least we got it working. Here, have a beer. Okay, so I don't know, it's 10 o'clock. I always say I'm going to go to 11. It's a lot of effort with less torque than the EZ HDs and 4 times the cost. Yeah, I don't know the specs of this particular servo, of the XL servo. Is it? I know that it's power hungry. Like, it is drawing, you know, almost half an amp right now, just sitting here, not doing anything. And hey, Jared, do we have any HDD servos lying around? Oh, I have a bunch. Hold on. Let me grab one of our Easy Robot servos. Okay, so this is an HDD servo that I've never used. It's just right out of a Rolly box. See, I'm gonna sneak something to you guys, let you know what's going on here. See that Rolly? That's his LiDAR. I know, I'm releasing a small secret. So, you know that we've been waiting, you guys have been waiting anxiously for hardware, new hardware that Easy Robot's releasing. So, the initiative of Cynthium was to separate not just a marketing and brand, but also internally in the business. So we actually have 2 groups of the company now. There's a group of people who work just on Easy Robot. That is all they do. They wake up in the morning, they show up here, and they do Easy Robot. They focus their efforts on putting robots in the classroom so that people can, children can learn with. And because, we didn't really expect that to happen, but when we built the robots, it just fell into that market. And, we produce revenue from selling in the classroom. So we're not going to change that. We're not going to stop selling. So instead it made sense. The Easy Robot brand is more well known, in the classroom than it is in the hobby space. And definitely produces a lot more money in the hobby space as well. But what happens in the education space, right? But in the hobby space, you guys produce like tons of awesome features and you build stuff. So my strategy as CEO was to split the company into 2 and have staff on each side of the business. So doing so, though, has really helped relieve the stress of hardware. For example, Jeremy still works on the Easy Robot side. So he is responsible for hardware. So if you look at his wall here, you see all the different projects that he's got ongoing. And we have dates assigned to them. And now that the organization has... please release more. Jeremy wants me to get you to get me drunk, so I start talking more. So what we're doing is now that Jeremy's got a bunch of stuff on the go, and now that we have a new COO, so an operating officer. That's Terry Doyle. If you watch the Easy Robot team video, you'll see that guy. So he's from Silicon Valley. He lives down there. We have an office down there as well. We have an office in California as well now too. And what those groups are doing are working on the Easy Robot and Synthium side. Depends on who it is. And we actually are releasing the hardware. So I think the scheduled date for the new accelerometer is what, Jer?
End of March.
End of March is the new accelerometer, the new IMU. So it's an accelerometer, gyro, temperature. And then we release the indoor positioning system in when? We release the indoor positioning system on the end of March as well. So you guys are going to actually start receiving that. It'll be on the website in a month and a bit. It's done. These things are fully done. And then we release the LiDAR when? April? May?
It'll probably be April, May.
Yeah, so it looks like the LiDAR will be end of April, maybe end of May. So Jeremy's not sure. We have to, we're pushing the manufacturing really hard because they're manufacturing the robots like the JDs and the Sixes and Rollies and Adventure Bots. And to sneak other things in there for the hobbyists has been hard before, but we've worked out a way to make that happen. So we got the LiDAR working. Do you guys want to see the prototype LiDAR? You guys want to see what the circuit board looks like? Let me see if I can bug Jeremy and get one. Is it in the box jar? Or the IPS, I mean, sorry? Not the LiDAR, the IPS? Here, let me show you the prototype IPS. There we go. So this is not a dev board. Do you have the dev board here?
Yep.
Here, I'll show you the difference between a dev board and a prototyping board. So when we do development, this is a dev board. And we have, I don't know, a number of these. We could have 10, we could have 20 of these. All right? And these, what we'll do is see all these pins on here and all these other pins. What Jeremy will do is he'll make the board really big because we have to write code that's going to run on this thing. There's 2 cameras for the IPS. One camera is a regular, like an Easy Robot camera. The other one is the same as an Easy Robot camera, but it has an IR filter on it. Or actually, no, it has not an IR filter. It has a daylight filter. So it only lets infrared in. Okay? And then what ends up happening is all of the infrared can go through one camera and all of the daylight can go through the other. So you can actually see when your robot has a beacon on it where it is in the room from a little beacon. And then we have the beacon here someplace as well. Oh, Jeremy's grabbing it. I can show you what the beacon looks like. All right, so here's a beacon. So you clip this onto your robot and it has, actually it's kind of crazy to imagine, but this little beacon has a digital switching power supply on it. So it's very energy efficient. Doesn't generate any heat. Well, the LED generates heat, but the power supply doesn't. And the LED is an infrared LED, so it's really bright. And when you mount this in the corner of your room someplace, your software can always see where the robot is and you can drive it around like you guys have seen in the videos. So this is an indoor positioning system. It won't work outdoors, but it'll work indoors, and it allows you to do some pretty crazy stuff. Like you can say, you can set waypoints. You can also specify places where the robot should not be able to drive. So you can draw on the screen. You can say, this is a couch, don't go near this, or this is an entrance to a kitchen, right? So if you say robot, go to kitchen, the robot will know how to get to the kitchen. So it's pretty awesome. So this is a dev board. And then what happens is we work with this for quite a while till we get it working. And then once we get it working, then we move to a prototyping board. So this means this is closest that you're going to see to the production version when we start shipping it next month. Okay, this is the closest thing you're going to see. minus, what's that? 2 months, sorry, yeah, in March. Minus these wires. See these tiny little wires that are all here? So
Kind of easily really affects us, so it pushes our production schedule back.
what happened was Jeremy, he's got a, like, I don't know if you guys can tell the size of these chips on here, but like they're tiny. Eh? Like he does this by hand in our lab here, or in his lab. And he's got, and to put a prototype like this, to build one is really, really tough. So he has to solder these tiny little wires on, and doing something like this can take a couple hours. So we do 2 prototyping boards, one for him and one for me usually. And then I take the code that I wrote from this, once it works, and I put it onto this. And this is essentially what you're going to end up getting. It's got holes in it for mounting. You won't get these pins on the side here, but you will get 2 ports. This is a USB port, and this is a camera port. So you can run this remotely over Wi-Fi by connecting it to an EZB through the camera, and this will broadcast the data from the cameras. Or you can plug this into an IO Tiny, and it'll broadcast the data, so you don't have to have any USB cables. But for really, really high quality navigation, you can plug in a USB into it, and it'll power itself off USB. And you plug it into your computer, and you will get, and you'll get a really, really quality navigation for sure. Have I achieved artificial intelligence and self-awareness in the Commodore 64? So last week, this week, actually I hacked the Commodore 64, and I built a cable which allows me to hook an SD card to it, and I have every single game ever made for the Commodore 64 on it. And I also hooked up an HDMI adapter to it, and I actually have the Commodore 64 running 1080p on our 100-inch TV here at the office. So it's pretty awesome. Well, here's the prototype. And then as far as the LiDAR goes, here's the LiDAR. Oh, I gotta move the camera. Is it a black marker here? Oops.
I know what's going on. This
is flex.
So I do need to trim these guys before I get this walking gait right. Set them back into the rest position. There's a skinny black mark right here.
I don't know if that's gonna work. I think I need a marker.
There's some over here. Oh yeah, here it goes.
Oh no, this works.
The fat black Sharpie. There you go.
Oh yeah, perfect.
Back into the resting position. Yeah, I'm gonna have to modify these so that these 2 pieces don't run into each other.
Okay, here we go.
I'm walking.
This is the LiDAR here.
Shot.
So, oops, sorry about that. Keep in mind, it's not going to be big. This is a prototyping board, so I was explaining the prototyping before. So when it's done, what you're going to end up with is going to be just, let's see if we take this off here, just this part here. You won't have this big circuit board hanging off of it. You can clip it on or do whatever. So that's what it looks like. So that's pretty cool. It works really well. Yesterday we had Rolly driving around the office, self-navigating, doing his own thing. It's pretty cool to watch. All right. Well, we hacked a. Oh, you took the back off too? Oh no, I could put a EZB on here. I got an EZB. So this is the Bioloid from Robotis. So why don't we see if we can get this guy doing something? Let me put these servos away and clean up this desk space.
It's kind of impossible to make this guy walk, but I'm gonna have to
Weigh his feet down better.
account for his top heaviness.
Also, I saw when you're making a move. What's your... So where's your walk forward you were doing?
No, I'm not actually. No, I'm just doing
Oh,
that.
okay.
The frames are
Then
down.
set these down. Turn this down steps to 1. And turn this delay to like 45. And try it again. And see if that granularity, he doesn't flip. See if you can make him just move a tiny little bit.
Yeah, I'm gonna make him move slow. But his knees were running into each other.
Oh, okay.
So I'm gonna have to chop those.
Alright, let's play with this Bioloid. So the only thing is, it's actually kind of interesting. This robot is like what, $2,000 US?
Like 1600.
16 bucks US. The only thing is it's missing is a camera and obviously Easy Builder. So we'll have to put a camera on him, I think.
Yeah, I was thinking we'll put him in his head. Be a good spot.
There's room for it. Okay, so Jeremy hacked this guy, made it so we can control him. So let's see if this works. Is there a switch on this thing, Jer?
Oh yeah, just connect those.
Okay.
That's kind of your switch.
My switch. Okay. So Jeremy also made me a schematic of all the servos. So let's see, I'll load up a new project in Easy Builder. And
We're gonna have to get rid of some of that. Both sides.
should connect to the Wi-Fi first here. Okay, so we got servo port D5 we're using, D3, D1, or V1, sorry, and then 2, 4, and 6, 7,
Make some noise, everybody.
8.
Turn on your speakers. Probably be a good time to do so. Sorry, DJ. I'm gonna
9,
make some noise.
10, no 10, 11, 8, 12, 13, 14, 15, 16. Okay, that should do it. And these are all running protocol 1 because it's the AX12s on these things. Cool. Now we can add an auto position. Perry, you know my first computer I think was actually I know what it is. It was an Apple II. I still have it. But then I got a Commodore 64 after that. and an Atari 5200, Atari XT. I think that's what it was, or XL. Let me see. It's Atari XL 400, something like that. XL 800. Yeah, this is it here. This one, but I don't think it had such a big back. I think it had a shorter back on it, like this. 800. Yeah, it was the Atari 800. This is this one here. This is the one I had after my Apple II. I had Pole Position for it and Qbert. Those are my two games. Okay, so now we got the drawing. We have to add each servo to here. So I'll go add a servo. Actually, see if we can find a picture of the Bioloid arms out. There we go, look at this. This is the picture we want. That's the picture we want. Let's grab it. Let's put this into Easy Builder here. There we go. Nice. All right. So this one and another servo over here. 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 And this makes things so much easier. Then you see people, like, when they load up Arduino on the internet and they're like, let's make a robot walk, and they start writing servo movement codes. Like, I don't know why people don't realize by calendar that it's not 1972 anymore. These engineers writing all this code. Consumerism keeps getting advanced, right? We keep making the world better. But programmers and engineers keep making the world more complicated for other engineers. There we go. Look at that. Okay, so this is going to be V5. This will be V3. And this will be V1. This will be V2. V4. Thanks a lot, Jeremy, for doing all this, building this robot. V5 is not working. We'll have to check that one out in a second here. Now we got V7, V8, V11, V12. The only thing I'm not good at is making robots walk. You know who made the JD walk? That was, we had that, he was, what was his name? He used to work with us. No. You made it walk originally. Yeah, Jeremy made the first JD walk in New York in the hotel room. The night before we had to present it to a lot of people. Yeah, that's right. But then who, what was his name, Vasily? Farage, yeah. Farage. Yeah. It's very meticulous. It's not a lot of time on it. Okay, cool. So the only servos that seem to be missing now are his ankles, which is 7 and 9. So I have to add this one, put it here, and this one, put it here.
Well, I don't know if we're gonna get him walking tonight, guys.
So this one will be
Some kind of
17.
Energy. One down.
This one will be 9.
We'll see. Yeah, got him bouncing on one foot, so that's a win.
Cool. Okay. So let's make sure that we're not missing stuff, because 17 and 9 don't seem to be working.
ROB that we had last week. These are from that. Still gonna do a bit of improvements on it. I'm gonna speaker from the out timing that's inside. And also wire the limit switches so that
Alright.
this part comes down, it'll be detected. And yeah. And we'll go, I don't know, with the years or something.
So- We move this thing differently. There we go. So some servos aren't working. This one here.
I think they might be called a unit different than a servo. Wedge used them when we were testing.
Oh yeah, that might make sense. So probably. How are we gonna?
Hopefully a bunch of them are just one.
We're gonna save this. I'll call it Bioloid, so I don't lose this project. But let me see here. Bum, 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 bum. So to find all the servos, you wonder if there's a way like I can say, tell me all servos that are here. I bet you if I send a ping command to 0xFE, it'll return back a whole bunch of packets, and each one will be every servo that's on the chain. Yeah, I should look into that, see if that's a thing. Because otherwise I have no way to tell what servos I'm actually controlling. So we can try pinging servos though. We can ping this one. Oh, V1 responded to ping. What's the paper say? Paper says there is no V1. So one of these is going to be a V1. Which one do you think it is? Oh, it's that one. Oh, no wait. V1 is there. Never mind, I lied. Okay. V2. V5. Let's try pinging that. V5 did not respond. Okay. Let's just try going through each one here. I should have made it a V6. V7, 8, 9. Okay, 9, 10. There's no 10. Let's try 10. Okay. 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8.
it's
9,
more room for flexibility.
12, 13, 14, 15, 16. Let's try 17. Oh, 17 responded to ping. Yeah, 17's there. What, 18? 19. Oh god, this is gonna take forever. 20. 21. 22. Do you guys know, did I make a, I'm gonna check and see. I think I made a command that allows you to actually to ping in Cynthium, or sorry, in Easy Builder from the Dynamixel control. Let's see. Is that documented in here? No. It is not. Okay, if it's not documented, then I should add it, because I'm pretty sure if we look inside of the code, let's see. Here, we have an easy script function. Oh, here we go. Get Dynamixel ping. Boom. Here's a command. So let's add a project. I should update these. let's add these right now. Get Dynamixel temp. Get Dynamixel load directory. Dynamixel load. Dynamixel ping. Dynamixel position. There we go. And these all accept a port. Yeah. So let's modify this. Marco, the Commodore 64, that was a pretty cool computer back in the day. It was good. It was like the best gaming computer. Not a lot of people use it for programming. People just use it to play games. It turned into like the Nintendo before the Nintendo. So let's edit the Dynamixel here. Let's add some details about let's see, source code, instructions. Electro wiring, here we go. So let's add a piece of code in here that says, or a piece of bit that says easy script commands. There are a number of easy script commands added with this control. The commands are as follows. So the commands are these. Dun, dun, dun. I'm just going to modify this plugin here and make it so you can see what I'm doing. Oh no! Took my camera right off. Jeez, making a lot of noises here. There we go. Oh, you never saw the Dynamo ping command? Yeah, you're gonna see it now, Marco, because I'm adding it to the manual. So it looks like it's something that I didn't add to the manual before. It's unlike me to miss something like that. But we caught it, so here we go. So this get Dynamexel temp returns the temperature, temp of the specified servo. Get load direction returns the direction of load on the specified servo. And then get load returns the load of the specified servo. And get ping returns a ping response if the servo exists, otherwise returns false. And then get position returns the position. There we go. Here, let's save this. And now, oops, that servo command will be here. There they are. Oh no, I didn't do a good job of editing that. Perfect. Oh yeah, look at that. Boom. So there's the servo commands there, Marco. So you watch what I'm going to do here. I'm going to write some code that's going to, it's going to ping and check the servos. So what it's going to do is I'm going to, I'll do a loop. So we'll do a repeat, this one here, repeat command, and then end repeat, and we'll say servo, and then variable start. I think we can I go V0 or V1, and then end V100. Increment by 1. What will that do? Error. String is not the correct format. I guess it has to be a number. Okay. What if I take a servo like this? I say port, and I say it's a V1. Can I add? Can I say port equals port plus 1? Can. So let's print port, and let's print port. Oh, it didn't change. Port, oops, port equals port. Error, you cannot add. Okay, so I made it V12. Bum, bum, bum. All right, so here's what we have to do. We have to do a repeat. I think it makes sense for me to make a, so yeah, well, I think I have to make a function for this. So I can go 1 to 100, and at 1, I can call it port equals V plus servo, and then I can say ping response equals ping port. And I can say print port plus response. And let's run that. Error requested v1 was not found. Learn 5. Between v0. What is going on? I guess I can't loop through servos. Well, that sucks. Oh, yes, I can. Because there's 24 servos, right? Which means that 23 is the first one. So 24 will be
It's definitely possible to make this guy walk.
25.
He's able to balance on one foot, so. There you have it.
26.
Getting these.
There we go. So it's looping and it's finding servos. But it errors out when no servo is configured for this ID. But I can change that. I can save. There's a big hot glue sale I'm missing. Great job for both of you once again. This is fun. I mean, seriously wanted to do one of these about advanced actuators. You know what, Perry? I'd love to see one about actuators because surprisingly, I'm not really much of a hardware guy. I keep getting confused as being a hardware guy because I work in robotics, but I like doing software. Whoa, Jeremy, you're so close. Jeremy on his channel is getting his robot to walk.
I'm getting close, but if my movements are too large, you're going to have to fine tune them, make more of them.
What's an infinity stone?
It's part of the Marvel universe. You ever see Avengers?
I've seen Avengers, yeah.
Yeah.
Was that the thing that they were trying to get?
Those like gems, those.
Oh, that's the Infinity Stone. Infinity Stone, cool.
Thanos gets all the Infinity Stones in the last Marvel or Avengers. He does some crazy stuff.
Crazy stuff. Well, Perry's trying to out-nerd us right now.
Really?
Yeah, he definitely did. He's talking about something I didn't even know.
I remember making that frame, but that's kind of neat.
I'm going to have to write some code, I think. I have to write some code that goes through and finds every servo on the Dynamixel chain.
It's a good idea.
Because I don't know how else to find the servos. They're hidden. But I could do it. It'll be easy. I have to make a bunch of changes to the Dynamixel plugin anyway, so. I had some lists of things I was going to do tonight, too, and I'm way too tuckered out. My brain is dead.
Mine is too.
Yeah.
I got a headache.
You know what?
It's all that hot glue, I know it.
Will's head just exploded. Yeah. Will died. All right. There's only 6 people watching, so I'm good to kill this now.
Yeah, I think it's
Getting tired. So, everybody who needed to know of Dynamixel servos, how they worked, hope that was helpful to you guys, especially Marco. Seems like you got your servo working. That's pretty awesome. I'll play with this Bioloid next week. What I'll do is I'll make the changes to the plugin, and then we can start making the Bioloid do stuff, and I'll add a camera to it as well. Cool. And of course, if you guys have any other questions and things that you think that you'd like us to do, let us know. And Perry, if you want, I'm going to make a tutorial on how to actually do a live stream, like where to get the software and how to set it up. So I'll do it on the website. I'll have some time this week. I should do that as well. And then we'll get you to, because I want to see I like seeing people's building areas. Cool. All right, guys. This is us. Me, Whoa, what's that? Okay, we'll see you guys. Thanks a bunch.